Hello, Science 10, and welcome to Lesson 8, Ionic Naming and Formulas. So today the goal is, in this lesson, to learn how to name ionic compounds and demonstrate that, as well as demonstrate how to balance the charges of ionic compounds when they're in their ion form. And lastly, how to create a chemical equation, essentially just a chemical formula that has balanced charges. So we're going to start here with ionic naming. Now, your notes don't follow my exact writing here. So just kind of go with the flow and I will read it to you and then you can add in as you go. So ionic naming and formulas. Ionic naming is not easy, but it's logical. All right. So what you're going to do, your notes say just put the blank and the anion name together. So what your notes are trying to say is just put the cation and the anion name together. Or, in other words, first put the metal and call it by its name, and then use the non-metal and add an IDE ending. So for your notes, it says make sure to specify charge for, ignore that part, and ignore the second blank. So honestly, for ionic naming, all you need to say is naming is easy. Just put the metal and the non-metal name together. Then right here, add add the IDE ending. So you can either cross out everything you have and just write this or just add to it. So when you are naming ionic compounds, all you have to do is just name the first element, like this one, magnesium, and then the other element, the nonmetal, call it fluorine, but instead of finishing it with that, you have to add an IDE ending, so it becomes fluoride. This is something you are already doing. You just didn't realize it because you were using the word ions. When we were making ions, I said you had to call the metals magnesium ions, and you had to call the fluorines, which were negatives, a fluoride ion. Now we're just dropping the ions because now they're coming together as a compound. They're no longer single ions, and now we would just call it magnesium fluoride. We're going to do a bunch of practice with this, so don't worry if you're not quite 100% sure how to do this. This is what we're going to do in class together. So just remember metal name first, non-metal second with an IDE ending. Now, writing the chemical formula is where it gets a little bit trickier. Okay, so follow along with me here. We're going to do lots of practice with this. So we're going to start by writing out the symbols for both the metal and for both elements, the metal before the non-metal. Okay, so we're always going to put the metal first. Then we're going to find the most common charge, or find the charges for the cation and the anion. So find the charges for both elements off of your periodic table. We're then going to find the lowest possible ratio where the total charges balance. Now that might not make sense, but essentially what it means is when you have a compound like magnesium fluoride, as a compound, it can't have a charge. It needs to be at zero. It's net, it's two ions cannot be, they have to balance each other out so that overall the entire compound is a zero. So its charge is a zero. So the positive charges on the metal and the negative charges on the non-metal have to end up equaling zero. Once you figure that out, you're going to write some subscripts, which just are smaller letters beside smaller numbers beside the letters. And that represents the charges from the metals and the non-metals. So it helps balance out and tells you how many atoms of each element you're going to have. And then last but not least, you're going to put a state on it. Now, ionic compounds are always solid at room temperature unless there's water present. Again, this might be like, oh my goodness, this seems crazy. I don't understand. We're going to do lots and lots of practice, and there's going to be no practice in this. We're all going to do practice together in class. So you're just getting your notes down. So I said earlier that you have to write down some subscripts sometimes because you have to balance the charges from the cation or the metal and the anion or the non-metal. So what you can do is you can use a little trick sometimes, but again, we'll use this trick only if we are making sense of everything. So what you do, there are shortcuts. When writing out the chemical formula for an ionic compound, usually what can happen is the charge of the cation can become the subscript of the anion. So what does that mean? here we have scandium oxide. Scandium is Sc3 plus. That's its ion. And O2 negative is its oxygen ion. So separated, this is what it looks like. It wants to come together to make the compound scandium ion. So what you have to do is find out how many scandiums you need to balance out your oxygens. Now, if you think about it, these two don't match. This does not equal 0. So what we would do first is say, okay, I'm going to add another atom of oxygen. By adding another atom of oxygen, like this, I'll show you. Adding another atom of oxygen, you have now changed this to 2 atoms of oxygen with a total charge of -4 between these two. That's -4. This is +3, so it's still not balanced. So you're going to do that. Well, let's see if I can undo this, guys. There we go. Okay. What you would do is you would then try and balance these charges. So I want this charge to balance. Okay, so I'm going to go like this. Add this over here. Rest of my story. Okay, here we go. So now I have a total of 4 negatives here. So 2 oxygen atoms for a total of 4 negatives. I have 2 scandium atoms for an overall charge of 6 positive. Again, these don't match. 2 and 2 is 4, 3 and 3 is 6. So we have to do it again. We have to find one more to see if we can get this to balance. All right. So now I have 6 positives and 6 negatives. That makes it 0. They're both equaling the same number, so they would altogether equal 0. So we call this the lowest common multiple being 6. 6 positive, 6 negative. So in order to do this, we ended up using 2 scandiums, and we ended up using 3 oxygens. Okay? So what ends up happening is you take that and you use it in your overall chemical formula writing. So how many atoms of scandium do I have? I have 2, so you would write Sc2. How many atoms of oxygen do I have? I have 3, so you would write O3. Now the little trick you can use sometimes is you can do what you call is the cross. So if you think about it, you saw the charge on scandium was 3 plus. Well, look at the atoms of oxygen. And the oxygen was 2 negative, and look at the atoms of scandium. So sometimes you can just take the positive cation, its charge, and plop it as the subscript, and take the negative charge and plop it as the subscript over here. Doesn't work every time, but most of the time it does. So that's just an example. So again, today was just about getting some stuff in your notes. We're going to do all of the practice. Oops, sorry guys. All of the practice and all of the stuff that we want to see on the board and together in class. So have your notes done, and I'll talk to you soon.